Hello everyone, myself Paula Makwana, Assistant Professor of EC Department at LJ Institute of Indian Technology. Welcome to the session of Satellite Communication. So in the last session we have finished chapter number 5. Now we are going to start with chapter number 6, that is the space segment. So in this chapter, what we are going to study is what are the different types of segment. First of all, what is segment and the types of segment. Based on that, what is anatomy for that? What is the power supply requirement for the satellite communication? And what do we mean by activity and how to control it? So basically, there are two types of segment. One is space segment. Second one is the ground segment. So in the space segment, you can say that it consists of satellite, right? So, and in the ground segment, it consists of different antennas, like a transmitting antenna and the receiving antenna. Alright? So this is the coverage region which shows the one satellite will receive the signal from the Earth station, transmitting Earth station, and based on the telemetry tracking and the command system, it will be going to be monitored, okay, and it will again retransmit the signal to this receiving antenna that receives the signal from the satellite. Alright, so over here, all the antennas are trans-receiver. That means it can transmit as well as it can receive the signal. Alright, so the space segment includes the satellite and the ground segment includes the transmitting and receiving antenna. Apart from that, it consists of telemetry, tracking and command ground station. Alright, that we use to track the satellite, to monitor its position and its altitude. Alright. Now, the anatomy of satellite. See, first of all, what satellite will include. Okay, see, for the satellite, the structure of the satellite, it consists of solar panel, the blue one and the red one, that is used to get the energy from the sun. Okay, and it will store the energy in its battery when the sun is not present. Alright, in the center portion, it will consist of input-output processor, right? The omnidirectional antenna is there for transmission and reception of the signal. The digital camera is used to capture the image from the Earth. Then applied computer. Then the image sensor. Then the high gain antennas. That means when we need to signal having a high output, okay? For that, we need the high gain antenna, transmitter and the receiver. The solar panels are there to provide the power supply to the satellite, the thermal bracket to protect the solar cell. Battery is used for the backup of the storage or backup of my energy, solar energy. The earth structure, star trackers, and the reaction wheels. Wheels are used to make a movement of the satellite around the Earth. Alright? So we can say that the antennas are used for the communication. Alright? The thermal control, that means used to maintain the temperature of the satellite. The purple one, that is for the mission payload. The yellow one is for the pointing control, how my satellite is pointed. Okay? The red one, that is used for the power supply, and the blue one, that is for the command and data, to receive the data and to command the satellite to orient its position. Okay, that signal will be received from the telemetry tracking and the command system. Alright, so this is the anatomy of satellite, that what is the function of different parts. Alright, now, as I have told you, the power supply requirement. So what does it mean? So the power supply requirement will be a primary for the satellite. Why? Because there are different components in the satellite, and to provide the energy, to provide the power supply to the satellite, we need a solar cell. Okay? So the solar cell is nothing but the arrays of cell in the series and parallel connections. Okay? Why we need a solar panel or the array of cells? Because the high amount of energy should be produced to get or to provide the energy to the different components in the satellite. Okay? So how to achieve the high power? So the high power can be achieved with the solar panels, which is arranged in the form of rectangular solar cells. Okay? It is already over here. This is a rectangular solar cells. With the help of the number of solar cells, we are able to produce the high amount of power, okay, by getting the energy from the sun. Right? So this is capable of greater power output than the cylindrical array. See, the solar array can be having a two structure. One is a rectangular structure, rectangular cells, or the cylindrical arrays. Okay? But compared to cylindrical arrays, this rectangular cells will produce the high amount of power. Okay? Now, what do you mean by attitude control? First of all, what is attitude? That means orientation of satellite in the space, and how it is going to be oriented to receive and to transmit power to antenna, which is on the ground. Okay? So to ensure that a directional antenna is going to be pointed towards by a specific earth station, okay, in the proper direction. Okay? For that, we need to stabilize its position. So that is called the attitude control. That can be done from the ground station. How? The telemetry tracking and command system will provide the command to the satellite. So by receiving the command signal from the ground station or in telemetry tracking and command system, the satellite will orient its space. So there are basically two types of stabilizing the satellite in two manners. The first one is passive attitude control system. The second one is the active attitude control system. Now, what does it mean? First of all, the passive system will stabilize the satellite without putting a drain on the satellite's energy supplies, right? So for that, a spinning satellite stabilization is used. Alright? So what it will do? It will do the gravity gradient stabilization, that means the interaction of satellite with the gravitational field of central body. Now what is central body? Over here, my earth is rotating around my satellite is rotating around the earth. So my earth is a primary body and the satellite is a secondary body. Okay? So we are going to use the gravitational field of this earth. Okay? So based on that, the stabilization of the attitude of the satellite will be done. Okay? With the help of a gravitational field of the satellite or against the central body. Alright? Now, what do you mean by attitude control system? In active manner. So the active control system that maintains the satellite attitude by sensing its orientation along the 3 axes. Okay? It can be done along the 3 axes, and it will form the corrections. That means in which angle my satellite should be oriented, right? Based on the measurements. So third method that we are going to study is momentum based stabilization, or we can say that it is called the 3 axis or board stabilization. Okay. Second method is using the electromagnetic points or the satellite which is relative, which is close to the Earth. And the third is mass exclusion devices. Alright, so this are the method is called the active control. So it is done with the help of sensing the orientation along the three axes. Now what are the three axes? Before starting the how the satellite will be going to orientate with the help of the its three axes like roll, pitch and yaw. The active control subsystem has three components. First is that sense the current attitude of the platform. That means what is my current attitude of the platform. Okay. Now, second is the one that computes the deviation in the current attitude from the desired attitude. The third one is the one that controls and corrects the computed errors. What is my desired attitude? What is my current attitude? And what is the deviation? That means what is the error which is going to be produced and how to correct in it. Okay. So this is the way that how the active control subsystem will work. Alright. Now, as I told you, the stabilization of the satellite will be done with the help of the active control system. It's with the help of three-axis stabilization. The three axes are roll, pitch, and yaw. Okay. So, what these three axes will symbolize? The yaw stands for the rotation of the satellite towards the Earth's center. Pitch means it is normal to the orbital plane, and the roll means it is perpendicular to Earth. Okay, you can see that these three are the perpendicular to each other. Alright, so these are the three axes. We can say that roll is for perpendicular to other one. That means other planes, right? The pitch rotation will be done like this. To the Earth center, the yaw rotation will be done like this, and the roll axis will be done like this, okay? Which is perpendicular to yaw and pitch, right? So for this, we require sensors. So sensors are used to determine the position of satellite axis with respect to the specified reference direction. Okay. So commonly we can use the reference directions are Earth, Sun or Star. Right? First, the Earth sensor, what it signifies. The Earth sensor infrared emission from the Earth are used for maintaining the roll and the pitch axis. Okay? And the sun and star sensors are generally used to measure the error in the yaw axis. Alright? So there are the two sensors. One is Earth sensor, which is used for controlling of roll and pitch axis. The second one is the sun and star axis. They are used to measure the error in the yaw axis. Alright? Now, if the error will produce, the error between the current attitude and the desired attitude is going to be computed, and the correction torque is going to be generated in proportion to the sense error. Right? So over here, we have studied what we mean by control system, what are different types of control system, and what are its examples. Alright? So based on that, we can say that the attitude control system can be done by the Earth, Sun and Star sensors. And the firstly, we can say the power supply. For the power supply requirement, we are going to use the solar cells. It can be a rectangular cells or the cylindrical cells. So out of that, we are going to use the rectangular cells for the high power generation. And we have studied the satellite antenna problem. Okay, so what we mean by segment, what it will include, what are the types of segment, and based on that, we are going to study how this momentum wave stabilization and the 3-axis stabilization will be done into the next session. Till then, if you have any doubt, you can ask me anytime on my email ID. Alright? Till then, thank you for your attention.